Maybe you know. Science meets the questions you never thought to ask. On a clear winter night in 2019, an astronomer named Edward Guinan stepped outside his home in Pennsylvania and looked up at Orion. Something was wrong. Betelgeuse, the bright red star on the hunter's left shoulder, the one he had watched for 40 years, was fading. Not flickering, fading. By February, it had dropped to less than a third of its normal brightness. The internet panicked. A star 700 light years away was dying in real time. And somewhere deep inside it, a clock was ticking. Orion is the easiest constellation to find in the night sky. 3 stars in a row, the belt. Above them, the hunter's left shoulder, glowing a deep, unmistakable red. That red, that is Betelgeuse, pronounced Betelgeuse if you grew up in the 80s, Betelgeuse if you grew up in Arabic. Its name comes from the phrase, Yad al-Jawza, the hand of Orion. For thousands of years, sailors used it to navigate. Mayans built temples aligned with its rising. But here's what you weren't told in school. Betelgeuse is not a normal star. It's a red supergiant, the bloated, dying carcass of something that used to look like our sun. It's roughly 700 times wider than our sun. If you dropped it where the sun is right now, the surface of Betelgeuse would swallow Mercury, Venus, Earth, Mars, and reach almost to Jupiter. Earth would be vapor inside its outer layers. And it's old, only about 10 million years old, which sounds young, until you learn that stars this big burn through their fuel obscenely fast. The sun has 5 billion years left. Betelgeuse has maybe 100,000, maybe less. In 1836, the astronomer John Herschel, son of the man who discovered Uranus, pointed his telescope at Betelgeuse and noticed something odd. The star was getting dimmer, then brighter, then dimmer again, over months, over years. Herschel was the first person to document, in a notebook now sitting in an archive in London, that Betelgeuse pulses. It breathes. The reason took another century to figure out. The star is so massive, its outer layers can't decide what they want to do. Gravity wants to crush them inward. Heat wants to push them outward. The two forces tug back and forth in a slow, lopsided rhythm, roughly every 400 days. So Betelgeuse swells, shrinks, swells, shrinks, sometimes losing material into space the size of a planet. For 200 years, we thought we understood this dance. We even had a chart. And then in October 2019, the chart broke. Edward Guinan, a professor at Villanova University who had been measuring Betelgeuse's brightness for over 40 years, watched the numbers crash. It wasn't dimming on schedule. It was crashing, and nobody knew why. To understand why a star fades, you have to understand what it actually is. A star is not a ball of fire. A star is a balance, a war between two forces. Inside the core, hydrogen atoms are slammed together so hard they fuse into helium. The reaction releases an enormous amount of energy. That energy pushes outward like a furnace trying to blow itself apart. Gravity pulls inward, try to crush it. For most of a star's life, these two cancel out. It glows quietly for billions of years. But once the hydrogen in the core runs out, the balance breaks. The core contracts. It gets hotter. It starts fusing helium into carbon. The outer layers can't keep up with the temperature change, so they swell, sometimes 1,000 times. That's a red supergiant. That's Betelgeuse. The surface is so far from the core that it cools to around 3,500 Kelvin. Hot, but cool for a star. That's why it looks red. Imagine a candle flame the size of the inner solar system, sputtering at the top. Every flicker is a continent of plasma rising and falling. And every flicker means it's running out of fuel. For decades, astronomers thought the 2019 dimming meant one thing. Betelgeuse was about to explode. Headlines went wild. Articles predicted a supernova within months. Twitter accounts opened daily betting pools. But here's where it gets strange. When Andrea Dupree, an astronomer at the Harvard-Smithsonian Center for Astrophysics, pointed the Hubble Space Telescope at Betelgeuse during the dimming, she saw something nobody expected. The star wasn't shrinking. It wasn't collapsing. It had burped. A massive bubble of plasma, roughly the size of Earth's orbit around the sun, had erupted from the surface and floated outward into space. As that bubble cooled in the vacuum, it condensed into dust. a dust cloud the size of the solar system. And from our angle here on Earth, it just happened to drift directly between us and Betelgeuse, like a curtain across a lamp. The star wasn't dying. It had just thrown a tantrum. By April 2020, the dust dispersed. Betelgeuse came back, but Dupree's discovery raised a darker question. If a star can lose that much material in one event, what does that say about how stable it actually is? The answer is not very. In 2023, a team led by Hideyuki Seo at Tohoku University in Japan published a paper that made other astronomers stop scrolling. They had run new simulations of Betelgeuse's interior, and the simulations suggested the star had already moved past helium burning, already finished it, already started fusing carbon. To understand what that means, a star like Betelgeuse spends roughly 8 million years burning hydrogen, then about 1 million years burning helium. Then it switches to carbon. Carbon burning lasts a few hundred years. Then neon, about a year. Oxygen, months. Silicon, a single day. And then the core collapses and the star explodes. Seo's team estimated Betelgeuse may have been in carbon burning for centuries. Other models, like those from Laszlo Molnar at Konkoly Observatory, disagreed. They put the star deeper in helium burning, with 100,000 years still to go. The honest answer, nobody knows. Because everything we're watching happened 700 years ago. The light reaching your eye right now left Betelgeuse around the time the Black Death was tearing through Europe. The star you see may already be gone. You're just waiting for the photons to catch up. And just when you think we've figured out the timeline, the star throws another curve. In 2024, astronomers at Flagstaff Observatory noticed something nobody had thought to look for. Betelgeuse might not be alone. The data suggested a smaller companion star, an unseen partner, orbiting once every 6 years inside Betelgeuse's own outer layers. They nicknamed it Beetle Buddy. If the companion exists, it changes everything. The pulsation patterns we use to predict the star's age might be wrong. The 2019 dimming might have been caused by the companion plowing through dust, not a surface eruption alone. And the brightness data going back to Herschel's notebook might need to be rewritten. As of 2025, the companion hasn't been directly imaged. Hubble is too small. James Webb is the wrong wavelength. We're guessing. Meanwhile, Betelgeuse keeps pulsing, keeps swelling, keeps losing mass, about the weight of Earth's atmosphere every year, drifting off into space. Somewhere inside, a clock is ticking. We just don't know what it's counting. Here's what makes this personal. When Betelgeuse finally does explode, you will see it. Not on a telescope, not on a screen, with your own eyes. The supernova will be brighter than the full moon. It will cast shadows on the ground at midnight. For a few weeks, the night sky will have 2 moons, one rocky and gray, one blazing in Orion. You'll be able to read by it. After a few months, it will fade. After a year, it'll be gone. The constellation Orion will lose its left shoulder. Forever. There's no danger to Earth. 700 light-years is far enough that the radiation can't hurt us. But it will be the first naked-eye supernova in our galaxy since 1604, when Johannes Kepler watched one for 18 months. Everyone alive today, every parent and every child, would witness an event that comes around once in 400 years. And here's the gut punch. It might happen tonight. It might happen in 100,000 years. Right now, in your sky, a clock is ticking inside a dying star. The signal that it has ended hasn't reached us yet. It is, by definition, already in the mail. In 1836, John Herschel circled a star in a notebook and wrote variable. Edward Guinan watched Betelgeuse for 40 years before it surprised him in 2019. Andrea Dupree caught it mid-burp through Hubble. Hideyuki Seo said the clock is faster than we thought. Laszlo Molnar said no. Slow down. We are arguing about a star that may have already died before the Crusades. The truth is, every clear night, you can step outside and watch a 10-million-year-old dying giant flicker on the hunter's shoulder. Most people don't even know to look up. They walk past Orion the way they walk past a tombstone, never reading the name. But the name is there. The hand of Orion. Betelgeuse. Betelgeuse. And someday, maybe tonight, maybe 99,000 years from tonight, the lamp will go out and the curtain will come down for the last time. If a star this big can fade in a week and fool half the planet into predicting its death, what else are we wrong about up there? Next time, we'll talk about a star that did the opposite, a tiny faint speck in the constellation Sagittarius that, in 1975, suddenly brightened 10,000 times in 3 days and turned out to be something we still don't have a clean name for. Hit subscribe so you don't miss it. Thanks for watching. If this sparked a question, drop it in the comments. It might be your next video. We'll see you next time.